Today is June the 11th. This is Addison Schonland. My guest today is Anders Forsland, who is co-founder and CEO of Heart Aerospace, based out of Sweden. But Anders, you're now in LA.
That's right.
Thank you for talking with me today. I appreciate your time. So if we could start, what I'm interested to know about, let's talk about the company and its progress.
Yes. So where do you want to start? So essentially, Heart has now been around for about 5 years. And we're getting into a very interesting stage. We've been sort of gradually demonstrating the core technology. So for those of your listeners and viewers that are not familiar, we're building a 30-seater hybrid electric aircraft called the ES-30, and we are approaching on our within the next year doing our first flight of this aircraft.
That's great news. Expectations for growth? How do you see the market evolving?
Do you mean growth in terms of our company and?
Well, I mean, the market demand for the airplane obviously has existed. You've orders.
Yeah. Obviously, we have we have customers all over the world. So obviously, our anchor customers are United, Mesa, Air Canada, but that have all made pre-orders of this aircraft, Rockton Air Leasing, but also obviously airlines from all over the world that have done LOIs, etc. So some of our partners include Air New Zealand and SAS as well. So where I see right now is, yeah, I think that the market for the type of aircraft that we're doing is showing a tremendous potential for growth.
Right. Your timing, I think, is very good because of just the way regional flying is struggling. One of the things that intrigues us is the fact that since the great retirement after the pandemic or during the pandemic, are you finding it difficult to find skilled people in the industry, even though you've got all this demand for the product? What we're hearing about is supply chain trouble, and biggest problem being skills.
Yeah, I mean, I think that this is a really a passionate topic of mine. So first of all, I think, looking at the sort of, going through the sort of development phase of the program into the production phase of the program, there's the sort of early stage engineering talent that you need, but then obviously there's also how do you build a production plant, and how do you actually make sure that your suppliers have the production capability we need. And I think that, first of all, as a mission-driven company, I think we're showing that we have a very good opportunity to attract the right talent, especially among young people that are coming out that want to work in aerospace. They want to see themselves as working on something that's part of the solution rather than the problem of emissions. Sort of certainly a big motivator for me, and I think if you look at this industry, there is actually, we've been on this pathway of diminishing returns. Actually, I used to work in jet engines, and part of my sort of PhD and where I got the sort of the drive to start Heart was reading a few papers on this sort of, the diminishing returns of technological evolution when it comes to the standard jet, the standard type of propulsion. Our market, as from a commercial perspective, aviation is growing exponentially, 4 to 5% every year. That's a great curve. So from a market perspective, this industry is in a very good shape. From a technology development, we have the inverse. We have like a negative exponential curve, which is sort of trending towards a flat line. Instead of trending towards a vertical line, it's trending towards a horizontal line. And that is the evolution of fuel efficiency of our products. So for every time we build an aircraft or an engine that is 0.1% more fuel efficient, that costs us about 10 times what the last tenth of a percentage costs. And that line is flattening more and more. And what that happens in the sort of cycles of new products, you don't want to bring a new product to market unless it's like 20% better fuel economy in the last one. You need that to amortize the cost of the development. We're seeing that the industry is now pushing their lead times and their innovation cycles further and further away, right? So from a product development perspective, I mean, quite frankly, it's not a very exciting place to be as an engineer.
Right.
So what is the next frontier? Like, we need to shift in a paradigm shift, right? So we've essentially gone from sort of this going into hybrid electric is the biggest thing since the jet age. And then you end up on a drastically different curve. When you start implementing the hybrid electric things, obviously our aircraft flies, flights with zero emissions up to 125 miles, 200 kilometers. And then as we progress there, we fly 400 kilometers at about 50% reduction in emissions. 800 kilometers is more like 17%, but it's very, 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 very attractive. So even if in that high end of that range, the hybrid electric propulsion becomes this viable option for the industry as we look to that new paradigm to push fuel efficiency even higher. And this matters, right? It matters not only from an environmental point of view, which I think is one of the biggest crises we're facing as an industry, but also obviously there's been this tight interplay between how fuel efficient aircraft we have and how competitive air travel can be as a whole. So this is the drive towards fuel efficiency has been on commercial grounds, and obviously stopping and realizing that we're sort of hitting a wall of diminishing returns. I think it's really imperative for this entire industry to find a new sort of trajectory that we can start optimizing on. And that's very, very different from what we've been doing in the last decades. We've been on this path of sort of refining. Now we have to start looking at more holistically around architecture, airframe integration, et cetera. Anyway, I'm just, oh yeah, I don't know if I answered your question. I just started talking about the things that I'm passionate about. We can talk about production as well, because that was the other part of your question. I mean, it's interesting that we're also seeing this production bottleneck. And so I think that when we're looking at this, the industry needs to move in a direction of more, I would say, more automation when it comes to the production of aircraft. I think there's been a lot of technology development in automation, but essentially what we're offering as a clean sheet design is there's this thing in product development like Conway's Law, which is that every product that you have is by necessity a reflection of the production system that built it, and specifically the communication structures in the production system that build it. So I think that as you're, while we've been trying to bring in new materials, new production systems, new automation into our manufacturing lines, we're sometimes a bit constrained by the fact that the aircraft we're working have been working on as an industry have been iterations of aircraft that's been along, since before the end of automation. So to really leverage these new production paradigms, you need to design the product and the production system in parallel.
Right. You're in a very complex place.
Yes.
So your factory's in Gothenburg, Sweden.
Yeah.
And you're now building a US-based R&D hub.
Correct. Yeah.
Can you walk us through the thinking about that?
Yeah. So first of all, one thing is, historically, HART started with we were part of the Y Combinator accelerator program. Just give me a second here. I feel I have notifications popping in my ear. So this just adds to the 2 seconds. All right, sorry. So yeah, so HART started, has had a journey of being active on both continents. So essentially, we started a part of Y Combinator in 2019 with the heavy support from the airlines in the Nordic, where we had Bra, SAS, and Videre all writing LOIs for us. We had the Swedish Innovations Agency funding about half our development. So we had the mandate coming from, especially the Norwegian government, that has this mandate that all their electric flights are going to be 100% electric by 2040. And so that was sort of a like inciting incident for the company as a whole. And obviously, in neighboring Sweden, we've built 30-seater aircraft before. We've built a lot of development in electromobility as well. Since then, we've seen that this sort of almost niche product that we were working on originally had a global appeal. Going through a few fundraisers, we saw that we got United Airlines, Air Canada coming on board as anchor customers, opening up the North American market. And we also saw that the investors that were coming in, like Breakthrough Energy, Lower Carbon Capital, so the Bill Gates' Climate Fund, etc. The sort of we saw a large interest coming from the largest aerospace industry in the world, or the largest aerospace market in the world. So Norway has 45 airports, and in the US there's 5,000. 500 of them are being used today commercially, but there's 5,000 airports overall. So we believe that this aircraft can make a big difference as new infrastructure in the US. And we want to make sure that we're building up a presence here in the US to sort of make that case. Also, we're in Los Angeles because I think it's a hot spot of innovation in aerospace. Has had that history, since the day of Douglas aircraft and whatnot, through the Skunk Works, the Lockheed Skunk Works, and most importantly, like lately, is the sort of ecosystem around new space that has popped up around SpaceX. So we've started recruiting quite heavily from there. What I think, so that's one of the reasons of opening up shop here, and the third reason, which is it's that the US is a very good. We're entering into a period of where we're going to be flight testing, and like many other companies, we're electing to do this early experimental flight testing here in the US for many reasons, including weather.
Right. Well, LA is certainly going to give you good weather for flying. Yeah. While we're on the subject of the US, obviously, Mesa is a regional carrier.
Yeah.
United is going to be looking at this airplane for regional work.
Yeah.
Regional flying is the biggest market for regional flying is right here.
Yeah.
How do you see this airplane fitting in regional air service for the US?
So, the first, going back to our journey here, right? So we started looking at, building these things for the market in Norway. So our vision if our mission is to decarbonize and democratize air travel, our vision is a world that looks like Norway does today. There's the sci-fi author, William Gibson, has said that the future is already here, it's only unevenly distributed. So in Norway, there is this point-to-point network where small communities are connected directly, and it forms the backbone of that nation's infrastructure. But when we started engaging with United and Mesa, we were asking, like, how many 30-seater turboprops do you fly? And they were basically saying none. And we were like, okay, why are you interested in this, the product that we're building? And they were like, but we did. If you go back to the 1990s, we served hundreds of communities, operated hundreds of aircraft, Embraer, Brasilias, et cetera, that have since lost service, right? And so what we're trying to do now is not just to create it's not to create a market, but rather to revive one that was there, right? And that sort of begs the question, how will it work financially? So the reason that Norway has this great infrastructure, it's no secret, it's that the Norwegian government is subsidizing it about 40% of the operational costs. And that sort of is enough to drive this network of Dash 8s that are creating this decentralized air service, um, and uh, and by going electric, you actually have that path to reduce organically the operating costs by about 40%. And this is actually not me only saying this. This was a report by NASA last year that sort of really pointed at this 40% being the magic number, where we go from this period of decline to a period of growth, right? So, I mean, and the potential for growth here is astounding. I mean, I mentioned there's like 90% of the airports, so 5,000 airports that do not have service today. And if you can just get the unit economics to work, you could make those electric airports.
Okay, so the way you view this is that your airplane's economics are such that they could reopen a lot of these communities that have lost air service.
Correct. Yes.
Okay, so one of the questions obviously is that well, hybrid power is a little different than pure battery, because pure battery is always going to run into a range problem.
Yeah.
What do you see as the speed, given the fact that as a feeder airplane, you have to run it close to network speeds because you're feeding a network? What is the speed going to be like on this airplane?
Yeah, I mean, this is a really good question. So, the aircraft is designed to be quite slow flying, so it's between 140 to 180 knots, and obviously flying so short routes, it's not the speed that is of importance, but it's certainly something. So essentially, if you're for the individual passengers, it's the door-to-door travel time that matters, right? So it's not going to be whether you sit on an aircraft for 30 or 45 minutes. It's going to be, hey, I'm flying from a small airport. I'm not going through the TSA. I'm not traveling a lot to get to the airport. But yeah, obviously, but the question of speeds, slot constraints, etc., for that hub feeder thing is obviously something that we're heavily engaged with airports discussing, and depending on what airport you look at, that could be more or less problematic.
So it's not. That's a tough answer.
Yeah. I mean, so obviously there's different yeah, I mean, I think that we'll find a good way for it, but obviously this sort of the landing and takeoff, making sure that it runs seamlessly with other operations is one of the things we're really like diving into hard now, because I think it is really one of those sort of constraints that might not be apparent starting off.
Right, and ways to improve the performance of the airplane. Yeah,
I mean, there's nothing about the aircraft in and of itself, like there's nothing about electric propulsion that is dictating that you need to be slow flying, right? So I mean, Rolls-Royce had this, they built the fastest electric aircraft in the world, and obviously if you're hybrid, you can increase the performance quite substantially. It's more about the fact that if you want to get real, like there's a correlation between fuel efficiency and going quite slow, right? So it's sort of the trade-off curve that you have to balance on with that. So there's certainly, you can just move on the sort of Pareto front there and build a faster flying aircraft as well.
And as my last question then, if you were to describe to an operator your sweet spot for this airplane, what is if you could give us an example?
No, I mean, I think that there's two, right? So, and maybe that's not, I don't want to pick one, but I mean, there's JSX is another partner of us. They've written a large LOI for aircraft. I use them extensively now that I'm in California. It's a great service. So, but basically you go point to point. You don't have to go to LAX. You go to Burbank and you fly to Oakland, right? Saves a ton of time, much more predictable, much more comfortable. You don't have to go through the hassle of the TSA, getting to the airport 2 hours ahead of time. So when you're going to San Francisco, it's a beautiful thing. So I think that's where I think one big use case. The other one is if you live in the hub feeders, so if you're flying from if you go into Aspen, say, and you live in Palm Springs, you fly to Palm Springs to LAX to Denver, and then so you fly Palm Springs to LAX on an electric, you fly LAX to Denver on a regular trunk route, and then you fly Denver to Aspen on an electric plane, right? So that's sort of the other sweet spot, and that obviously saves you a lot of time driving, or it creates a lot of flexibility for those routes where driving either due to traffic or due to geography is very punishing, right? And you sort of get away from checking in and checking out of the major airport.
Okay, well, sounds like a fascinating path you're on, and I'm for sure going to follow it.
Yeah, I mean, this is only the beginning, right? And I think that what you're seeing is that this aircraft is, if you get those operating numbers down, you could start, reintroducing that service. But I think you can also expand. Sort of a 30-seater electric aircraft has sort of the same operating economics, depending a little bit where you look at 2030 or 2040, say a 50-seater to a 7-seater aircraft, right? And those are the aircraft that operate sort of profitably when there's good road and rail alternatives as well, right? So the 30-seater market today is mostly constrained to places where there's not a lot of optionality, but I see this moving in more and more. And I think, so the right sizing for an electric plane is different than the right sizing for a jet engine, because jet engines really don't scale that well with size. So, and I think and so a lot of people are asking about this, and obviously we're building like larger and larger aircraft. We think that this can scale. The aircraft we're designing can stretch to 50 and 70 seats as well. But ultimately, like, people don't really buy airplane tickets based on how many other passengers are going to be there. They buy it based on price, right? So as long as you can keep the price down, and we notice that the people that are not sensitive to price, they prefer to fly by themselves in a private jet, right? So I think actually this, obviously we've seen this trend for many decades of bigger is always better, and it's certainly going to continue with the slot constraint and the trunk routes. But to complement that, I think this fine grid, the tributaries that are feeding the rivers, is going to open up a place in the market, and I think it's going to be hard to operate competitive trunk routes without having that feed.
Thank you so much for the chat.
Yeah, thank you.